Hey everyone. So thanks a lot for this very lofty introduction. But it's just me and my humble mustache, which is here. So I welcome you to this talk. We're going to discuss a lot of concepts which have not been discussed in privacy before, and I guess it would be one of the first times we are going to do a deep dive into it. And just let's get into it then. So I'm this guy. You know about this, so no need to read this. Privacy in modern times is actually something like this. You click yes, I agree, and you sign away your soul, or you burn your money and go to the Himalayas. I mean, there's no choice in between at this time. So, and why do people feel like this is because they see a few things. They see the mistakes every day. They see news items like this. Twitter advising all 330 million users to change their passwords. A gas state agency in India, leaks millions of Aadhaar numbers. Aadhaar is like SIN number here. So it's like that. And all of these things, when you go to the root of it, is very basic. For Twitter, it was actually plain text passwords and logs, something as simple as that. And for this, it was an unauthenticated endpoint, which was leaking PII. You could just go and do the increment ID thing, and you suddenly get all the information. So the other reason is that people know about this also now. They did not used to know this dark cloud in between, but now they know that there are data brokers who are, you trust a few of the services, you put all your data there. Some services you don't know you should trust or not, but I guess maybe just give some info to them, and then it goes on, gets into this dark area, and then everything gets collected, and suddenly there is this service which has everything about you. You never even expected this random ABC numbered corporation having all this information about you, but they have it, and people know about this now. So they're worried. They are genuinely worried. It's very difficult to solve these problems because there are economic incentives around them. Because for some businesses they are only going to run if they take in your data. But some legitimate businesses, they have to actually solve this stuff. So the theater of security and privacy looks like this right now. And I'll start from the perspective of privacy. We'll see the CISO's mind. It's kind of like this. It's not blank. We are going to fill this. So I think the first thing is like this. RSA, Log4j, big ticket items, they really are worried about all of that stuff. But then, behind there is something else also in the back of the mind. It's important for them to understand what's going on. So we'll zoom into it. And then we see that they know about some bugs, which are going to own them. Somebody must have mentioned them in some board meeting, a guy walking past. So they're worried about them also. It's not like they're not worried about it. And at the same time, there's another human, they know about. And this human is that sharply dressed colleague which they have, and they have like the CIPPE, etc. on LinkedIn. Okay, this person is the privacy officer, the chief privacy officer. So we start looking at their mind also now. Okay, and the chief privacy officer is worried about GDPR. You talk to chief privacy officers. Okay, GDPR is my stuff GDPR compliant or not, or like CCPA. And then they also worry about some conferences like IAPP, organizations like that, and then compliance, DSAR, is the data fine? They're worried about that. And then there's this nagging question that they always have. So on para 2 of a privacy policy, we say that we don't collect precise location, but on the random channel, I saw this map of our customers doing SBB bank runs, okay? And people were joking about it. So how did this information go there? So I think they are worried about stuff. But they just don't know exactly how to tackle it. But there are reasons for it. And during my movement from security and privacy and security altogether throughout these years, I have realized that privacy operations work like this. There are 3 buckets of people who touch privacy essentially. So I think the first is the lawyers on the side. They do high-level GDPR type mandates, very important. They're more reactive, so they look at privacy events very carefully on what has happened, what is going to happen, and they have a very compliance kind of mindset. Are we compliant with this law? Is it fine or not? This is very important for large organization to run efficiently, not get into trouble. And then they also rely very deeply with security data or privacy operations, which actually own in putting those laws in action. They try to implement what is going on. They're tracking all the changes, flows to all the data inside the org, run privacy assessments, data subject access requests, DSAR. These are all these terms you're going to hear in privacy. They come from a very safety kind of mindset. We have a responsibility to safeguard the data that is coming in. And then on the other side are developers. They are very decoupled from other orgs, as I have observed. These are the people who will actually solve a problem. So if some change has to be done in the code to keep the app safe, to implement privacy respecting features in it goes to them. So really the problem, the solution of the problem is there, okay? And then a lot of people are revolving around these buckets, gathering or not having the developers, get into the, I would say the same table, I would say. So there are common grounds in security and privacy. I tried to put them in this nice Venn diagram because Venn diagrams always look cool. So security folks, you can see they care about injection, auth bypass, network stuff, some CWEs, they care about, that path traversal, I guess. And then they also care about some other stuff. Like they care about data security and sensitive data leaks. There's a huge whole section about that, like CW200. They care about information leaks. It's not like they don't care about it. But they look at this from their angle, as if it's one of the points inside the thing that we have to fix, and we are done. The other folks, privacy folks, care about a lot of other things that these folks don't know about at all, like DSAR, DPIA, privacy impact assessments, So privacy impact assessments are run on spreadsheets right now in a lot of organizations. I've talked to a lot of organizations. To folks working in InfoSec, they would think, how can you run a whole thing like this? Like a provable thing where sensitive data, like are you recording precise location? It takes like 2 to 3 months for them to get this information from engineers. It's weird, but this is really what happens. So they care about this, and there is a common ground that is there. The goal is that we need to understand that common ground. So right now, the pull is too much on the other sides, but eventually we are going to fix this. So the conundrum is like this. There's a lot of code. It produces a lot of data. So the data that is coming in all these databases, going from one place to another place, going in the log, getting leaked somewhere, it's coming from code. Code is responsible for that. And privacy operation is like someone with a broom trying to, brush this water spilling on the surface. It's not going to work. They try their best. And going a little bit deep, this is kind of like an example of an actual code, where you can see that there's username, it's something that is coming from the user. And eventually, if you look at the code, you will see that it gets logged, in a log. And in reality, what's going to happen, because I've seen some operations inside, is they go to some 10 databases here and there, one other log service, running somewhere else. And then some innocent human, who never even cared about it, they have access to it. And they just don't tell anybody, because they don't care about it. But technically, it is bad because that's data that gets leaked and it's in front of someone who should not have it. So privacy operations are going to look at many places and trying to understand this. They will look at databases, trying to remove stuff from databases if they find private information there. But the reality is that the developer really knows where this data is, how we put them there. So there is an opportunity here to try to fix it at the left layer. And this is the whole thesis of this talk. We haven't even begun, So we'll begin. And the thesis is that if we can analyze code properly, we might be able to fix a lot of vulnerabilities that are in security and also at the intersection of privacy, so making everyone happy. So the goal is to develop privacy tools for developers and engineers. We'll see how we can build them. We use a technique called static analysis, age-old technique. We'll see how it works. So static analysis is analysis of a program or a piece of software before it even runs, and then predicting what's going to happen when it runs. So it's kind of like magic. So that's what it is. You have to understand a few concepts, sources. So if you look on the right-hand side, interesting points where the data can begin. So here is data coming inside this little function, and then trying to track it all the way to sync, so tainting it all the way so that you can do like a nice data flow analysis. So these are some sort of concepts you'll have to remember: sources, sinks, taints, and data flow. And like why we try to do this is because how humans understand code, we also understand it like that. When I told you about this piece of code, you started looking in your head about HTTP, then seeing, okay, it goes to location, and then it goes here. So computers also understand it exactly like that. So why not we just leverage this? So that's kind of like the thesis behind this. So looking at the same piece of code, this is how you would think inside your head. You would look at this HTTP variable, you will tag it in your head, you will mark it as source, and then try to see where it is going, and then see it goes to an info. Then you try to look at what is the type of this info. Okay, this looks like the logger, from Apache Log4j. Okay, this is interesting for me. I should start tracking it. So after this mapping has been done, you can ask this question. So this is your goal, when you try to analyze software. So find a flow from a variable, which is PII geolocation, to a sync log function of package Apache Log4j. So you might have this, thinking in your head, trying to understand a piece of code, and that's what you do mentally. So the goal of static analysis is to try to model this, using computers. We have been doing this for ages. Compilers have been doing half of this work all the time. So we are just going to leverage that. So why should we do this? Because code is actually the true container, producer, or mover of data. So why not just analyze data from that layer rather than just looking at it when it gets stored somewhere? So we can find bugs early in the software development lifecycle, try to fix things very early rather than trying to be reactive and trying to look at things at runtime. So how do we do this? So before we do this, we'll have to do a deep dive and understand what is even code. So existential questions like this in computer science can be solved by complex things like this. So I'm not going to go through all of it, but essentially what you need to know is that this is how computers are going to understand this little line, int y equals x plus 50. It converts it into this nice tree format. Just remember the name, AST. And then eventually, through this AST, we are able to get this control flow graph on the right-hand side, how control passes between different points inside the application, inside the function. Remember, we are not even executing anything. It's just statically analyzing the whole piece of code and trying to understand that. And take a good note at this yellow thing there, orange thing. So that's essentially where our data is. So with this information embedded in these nice trees and graphs that you see, we are able to get a dependence tree so that we know that the value of z depends on the value of y, depends on the value of x. So by doing this, you can see where we are approaching. We are eventually building like data flow of a complete application. So, but programs are more complex. They are not single lines of code. Real programs look like this. And they have more abstractions in them. So there are class and types which have been introduced. A variable can be a member variable. It can be a local variable. There is a package now, or namespace, based on what language you have. I mean, procedure, function, methods. I mean, these are all variants of things. So we have these new abstractions that have been added, and then there is a relationship between them. So, for example, this method getPatient that you saw before is defined in this class patient controller, which instantiates another variable, and the method also contains a call which is findById. So you can see programs will become huge, when you convert them to a graphical format, and that's essentially what we try to do. We try to achieve. So to embed all this information, an abstract syntax tree, the information about calls, information about data flow, we use an approach of building a graph, like a massive graph, which has all this information. And the base layer of that would be an abstract syntax tree. So it's a tree which has all the little information about, for example, here, x plus 50 equals y. So this kind of information is embedded in a graph like that. We'll have that information of the whole code embedded as one of the base layers. And then we enhance it. We try to build more information over it. So we have control flow and data flow information over it. And then eventually build more information over it where we can have a human kind of question that we can ask. Okay, give me all the methods which have patient in their name. So this kind of information is now embedded because we have this nice graph. This whole thing is called as a code property graph. A colleague of mine invented this. You can go on the Wikipedia article and you can read about this. So a big graph, and it's a queryable graph. You can query it and ask questions. So languages, different languages, whatever code is written in different languages, that's front end. And then the front end, creates this nice graph. And then you can query the graph using a query engine. So in real world, it would be like how you can operationalize is there's a Java app you have, and then it converts to this graph. And then you have this question, a human-like question that you had. You can ask this question, and then the graph returns an answer. It says, okay, I found one flow. Starts from HTTP, ends to the first parameter of info on this line, on this file. So you have a lot of this information embedded completely in it. How we can use this? So what if we could run thousands of these queries on millions of lines of code? Okay, it's not AI, it's just simple stuff. Okay, we are not going to do a lot of LLM AI stuff. It's very simple. Thousands of these queries, formulate these nice queries, and run this on millions and millions of lines of code. It's going to throw out interesting flows, which you can see, which are provable that this data went from here and ended up there. So that's essentially the way we can solve this. And to do this, we build this tool called Privado Scan, which starts scaling static analysis and tuned specifically for privacy. Privado Scan is open source. There are three components of it. There are three repos: Privado, Privado Core, and Privado CLI. There are rules which are defined in nice YAMLs, very easy to remember, very straightforward. The engine, it generates the CPG, converts these rules to actual queries, so these millions of queries, and then runs these queries on lot of code. And then you can view the results. By default, there's a JSON and something on the CLI, but then you can also visualize it on a community dashboard that we have. Privado is LGPL, so you can download and play with this. How does this work? So source code converts to this graph we talked about. YAML rules query, and then results. As I just told you, you get something like this. So 5 flows where data is flowing from flowing to AWS S3. So you can even embed these kind of syncs in the system. So it's flowing to a DB, it's written to a file, and then you can go through the system and understand where the data is exactly going. So you can try this out. There's a simple curl command here to try this out. You should not do this because, yeah. So, and then you can just run Privado Scan. We'll go to a demo now. I hope the demo works because we should start praying to the demo gods now. So, system is set up here. It's very simple. I think I should make this a bit smaller, I guess, here. Is this good? Okay. Okay, can everyone see this? Yes. Awesome. Okay, I need 2 hands, but one is occupied. So the brain has to think. Okay, so I have some commands already added. It says Privado Scan banking system backend there. Banking system backend is a repo. It has some sensitive data, and then we'll try to discover if it flows somewhere. I've already scanned it, so I know what happens, but it's for you to see what happens. So let's run this, and this is, so Privado is packaged in like a Docker container. So now this is running here. You can see that, we detected that the language is Java. It looks at configuration. It's trying to download some dependencies which might be there. So for example, imports, etc., that you do in Java, it's trying to understand all of that. And then it will start parsing source code. So static analysis takes time, so it's going to take time, but surprisingly, it's very fast. I was told that in some organizations that were doing static analysis, that they used to run their stuff on weekends and then go back, and on Monday they would come with like thousands of things in the list, and I never understood how people can do this. But this is pretty fast for the size of this code. So we ran a lot of passes over this graph. People working in compilers would understand what passes are. So we ran a lot of these passes over this nice graph. And we were able to detect a lot of things related to privacy here. So you can see there is some data elements. So we have 11 data elements total, one third party, and then 2 storages, and then information about those data elements. So they are also classified. So we have a way to classify those data elements also. You can see we have some passport information, age, phone number, date of birth, and where it is going. So for example, date of birth is getting collected in these routes. It's also going to this database, HDFC Bank 1. We understood because this information was in the configuration. For some things we can also detect third parties. So this is getting shared to this fast to SMS thing, and then there is a nice dashboard to view this also. I'll try to open it. Let's see. Okay, so this is how it looks. So you have these data elements on the left side, and then you see data going all the way on the right side. So here we can see like phone number. We were looking at phone number. We can see where phone number went. It was getting shared to fast SMS, goes into the storage, and then you can click on code analysis and see this literally line by line how this was going from one place to another. And then you can see eventually you created a URL connection, and then maybe the string in URL was fast to SMS, and then that's how it detected that essentially you made a call to that, and the phone number was a part of that message that went there. So this is an example. Contrary to a lot of what people say, I find this thing very interesting. Like stuff going into logs is one of the interesting things that I find here. So that brings me to the end of the demo. You can try to play around with it with your own repos also. Try with Java. Python is also there. Python is beta at this time, and JS is also beta, but I think Java is working very well, so please play around with this. Where do we go next? So I think if someone asked me what we should do, in privacy, this would be something very golden for me. A privacy policy, very high level stuff that, lawyer folks would understand much more better, with CIPPE stuff on their LinkedIn. We want to understand how they translate to GDPR violations, GDPR or any other law. So GDPR is like a, kind of like a larger term that I'm using for CCPA or any other kind of PIPEDA for Canada. So these kind of regulations which are there. So any violation connected with the policy that you already have in your organization, and then an actual bug inside the code. So this would be like the golden, kind of like the holy grail of getting privacy done properly. It's very difficult to do this. You can do half of it, you can do one piece of it, but through and through it's very difficult. But people are trying. There's a research paper below. You can see this. I mean, this has been talking about a very similar approach, and they are also doing something like that. And then, find these exact privacy violations and suggest some automated ways to fix them. We can definitely leverage AI or the advances in AI right now for that. I think the time is there. The models are just not yet there, but I think they are almost there. And then build a complete organizational data flow, not just by analyzing code, but also databases, APIs, document, or your complete infrastructure. So like a complete large map of where data can start from, where it can go. just by doing scanning of all these individual components. So till now we have been scanning something, some DBs here, and then someone looks at a document, puts it in a spreadsheet, sends it to somebody else. A lot of manual processes going on right now. We can do everything by just scanning all of these pieces one by one and then correlating them. That would be pretty interesting. Okay, I think we are almost at the end of this. So last comment, which I would want to say that if your clothes had as much value as your private information, I can bet some privacy policy would be there, and they won't mind asking you to send them your underwear before you order a cab. I mean, this is the state that we are in right now related to privacy. So please take care of your private information. That's all I would say. Here are some additional links for docs, rules engine for Privado. I also recommend you reading the NIST privacy framework, and not just the security one, the privacy one here. And there's a tool by Microsoft, data protection mapping framework, which maps all these different, these. We all know the MITRE attack framework or OWASP top 10, etc. I mean, in security we know this, but in privacy there's an effort to map all these different kind of standards into each other. So that's essentially what this is. Okay, and so questions.
Okay, so let's start with, there we go, amazing, magic. So do you think this approach could encourage organizations to retain PII in a dangerous way? And should we focus on privacy by design? Good question.
So I think this is actual privacy by design. I mean, yes, they are retaining your information anyways. You would be surprised to know how much information they retain on you, and you'll be surprised to know that they have no clue what to do with this. So they're already retaining it. I mean, there's no question about it. And every time someone says that we are not going to collect this or we are compliant with this, I think I can bet, I don't know, maybe it's too dangerous, but I will still bet that they have your information, okay, in somewhere, in some of the databases, and they don't know about it. So they're not wrong in it, it's just that they don't know about it. But since they are collecting it anyways through these various, means, a marketing person came in and then said, I need this thing in the analytics, can you put it? Nobody else knows about what they asked and where the data is going. The better thing is to get to have an understanding that it is going there and then stop it. So this, I believe, is a way to do privacy by design, by doing static analysis of code and actually understanding where it's exactly going. Does that answer the question, or I was just going around, beating about the bush?
We will never know if the person who asked the question is actually in the room. Any other questions? I'm not seeing anything popping up yet. Oh, never mind. That is a lie. So here we go. Is it even possible for this kind of analysis to help with the confused deputy problem? Your example of the incrementing ID revealing Adhar's numbers.
Can you remind me the confused deputy problem?
All right, audience. I don't know the confused deputy problem, so I'm lost.
It's like if you have a thing that's authorized to act as an oracle for decrypting something, and it'll just respond to whoever. So I guess they're talking about if the website is supposed to give you your information, but it's giving you her information, it's still supposed to get, the information is supposed to go from the source to the sink. So.
Okay, got it. Yeah. So I think when you actually do code analysis and try to understand how this information was collected, for example, let's take the Aadhaar number. So if you look at the system, you will see that the Aadhaar number was collected in this certain variable, and we see that it went all the way here to populate this template in this JSX file, and here it was going. You would have a complete flow of where the data went to. And if in between that, there was no check or authentication, you can actually prove and find it that this was missing. This authentication was missing, so this person is not authorized to view it. So you can find it. But if you didn't, I mean, obviously the flow is supposed to be there. It's a data that came from somewhere and is supposed to be shown on the site. But if it's not authenticated, you can prove it that this was not authenticated, so it's a violation.
Okay, and we've got another one. Let's see. Won't companies actually want to stay away from tools like yours so that they can keep claiming that they did not know?
100%. Like 100% they want to be away from us as much as possible. But 100% they will be slapped with like, $60 million fine, because like last week there were 3, in EU. So EU is very strict on this right now. Last 2 years they have started, clearing court cases which had been pending for quite some time, and they are going to get fined. So it's the same thing that happens in cybersecurity. So like fear-driven fixes, which should not be there. People should intrinsically be motivated to not leak information, but they don't do it. So the other approach is they'll get fined, and then they will come to us to either detect where the issue was there, or bake privacy by design the way it is supposed to be. But I would not be too pessimistic about it, because I'm interacting with a lot of companies, and they are really coming to us from an engineering perspective for the first time. Never experienced this. Like somebody, a large organization coming to us and saying, oh, we know that all of this stuff is fine with us, but we actually want to bake privacy by design. So it's a new thing, and privacy by design, and these techniques being pioneered here itself in Canada. I mean, it's a big thing.
All right, going once, going twice. All right, I think that's all we got. Thank you so much, Sushakra.
Okay.
Appreciate your
Thanks a lot.
time.